Okay, today, inshallah, we are going to talk about lecture 5. We are going to introduce lecture 5, random bit generation and stream cipher. So start with random bit generation at the beginning, how random strings and random bits are generated, the methods or the algorithms that are used in creating random stream, and then finally we'll talk about how to make or to use this random bit generation into the stream ciphers. Now we introduce random numbers. So a number of network security algorithms and protocols based on cryptography use the random binary numbers. For example, key distribution. Key distribution means if you want to distribute key or create one key or create multiple keys, you should use the random numbers to create such keys. And the key distribution used in the authentication. So whenever you want to make authentication, you should create a key, and this key should be random. This key should be random, cannot be expected. That's why random numbers are used in key distribution. Also, session key generation means for each session we need a key to define this session. This also should be random. And also generation of keys for the RSA public key encryption algorithm. We introduced the RSA public key encryption at chapter 2, and we introduced how to define random numbers, but those random numbers should be at the end should be prime numbers, should be prime integers and very huge or big prime integers. And also, random numbers are useful for generation of a bit stream for symmetric streams encryption. And that's what we are going to talk about today, the generation of a bit stream for symmetric stream encryption. Because we have a bit stream at the sender and a bit stream at the receiver, and then we want to send the bit stream at the sender in a secure way. So we use the encryption key to be random number. So how to define the randomness? How to know this number is random or not? We have two specific requirements for making a random number. The first one is randomness. Randomness. The first one is randomness. And the second one is unpredictability. Unpredictability. Randomness, you can say in a very easy way, it is the probability of having 0 or 1 at each bit is zero point 0.5. The probability of having the next bit should be probable 0 or probable 1 with equal probability. This is randomness. Unpredictability means using the existing bit stream, I cannot predict future bit streams. And vice versa means if I have a bit stream, I cannot predict the previous bit streams. So I cannot predict forward or predict backward. So those properties defines the requirement for random number is randomness and unpredictability. Of course, we are going to talk about these randomness and unpredictability in more detail. The randomness means the generation of a sequence of allegedly random numbers being random in some well-defined statistical sense has been a concern. So We need the random number to be random in a statistical sense, means the number of ones, number of zeros, the average number of ones, the average number of zeros, total number of ones, total number of zeros, and so on. This is statistical properties of the random number. And we use, or we have two criteria to validate that a sequence of numbers is random. We should know the uniform distribution independence. So the uniform distribution means the frequency of occurrence of ones and zeros should be approximately equal. That's what I have told you about the probability. The probability of having 0 or 1 is equal to 0.5. So, for example, if you have a coin and you throw the coin, you have head and tail. The probability of having head is equal to the probability of having tail is equal to zero point 0.5. This is uniform distribution. Each point in the sample space has the same probability. We have here in the sample space, we have 1 and 0, so 1 has a probability of 0.5 and 0 has a probability of 0.52. This is the first criteria. The first criteria is uniform distribution. The second criteria is independence. Independence means the subsequence independent on each other. The subsequences are independent on each other. For example, I cannot guess one sub key or substream from other parts. I cannot predict using the current bit stream. I cannot predict the next bit stream. This is independence. Independence means no sub part of the stream is dependent on any other subpart. This is randomness. What about unpredictability? Unpredictability means is not just what the sequence of numbers be statistically random, but that the successive members of the sequence are unpredictable. Not only random, but for example, on a long run, maybe the sequence repeated itself. So the sequence, they are random. Each sequence is random, but unpredictability is not existing. Because after specific steps or a specific length of the current bit stream, we will have a repetition of this bit stream. So maybe the hacker knows this period and then wait for that period to repeat and then predict the keys. And that's why unpredictability is also important. Not only randomness, but also unpredictability. And with true random sequence, each number is statistically independent of other numbers in the sequence and therefore unpredictable. And the word true here means that nobody can guess the next bit. Nobody. I have bit stream. I'm creating the next bit. The next bit has a probability of zero, have a probability to be 0 and to be 1 with equal probability. I don't know exactly the next bit will be 0 or 1. I don't know. I don't have an evidence of this. If I have evidence of this sequence is predictable. And this sequence, if it is predictable, this is not good algorithm. True random numbers have their limitations, such as inefficiency. Actually, if we talk about true randomness here, means that we use physical property from the computer, for example, the hard disk magnetic field, or you can say the motion of the mouse, and then start our random sequence. That's why the limitation of inefficiency means that you want to create random number, you will need hardware and software, and expensive hardware and software. But for not true random, this is deterministic algorithms, this will not be applicable, and you will have more cheap type of algorithms. So it is more common to implement algorithms that generate a sequence of numbers that appear to be random. It's better to make algorithms generate a sequence of numbers. That's better than true random numbers. That the true random numbers depend on nature or physical phenomenon like electricity, like the clock of the processor and other natural or physical uh, actions. Care must be taken that an opponent not be able to predict future elements of the sequence on the basis of earlier element. As I told you, the attacker should not be able to predict future stream given the current stream, or the opposite way around, when he has the current stream and predict previous stream. So he cannot predict forward or backward. And here we have a pseudo random numbers. Pseudo random numbers, pseudo random numbers, the numbers created by an algorithm. Cryptographic applications typically make use of algorithm techniques for random number generation. So they create pseudo random numbers using algorithms. These algorithms are deterministic. And the word deterministic here means they repeat themselves after a period. They repeat themselves after a period, and therefore produce a sequence of numbers that are not statistically random. Not statistically random. But we skip this with different techniques. I will tell you about them in the in the next slides. I will tell you how to skip this statistically or the statistical properties of the deterministic algorithms. If the algorithm is good, the resulting sequences will pass many tests of randomness and are referred to as pseudo-random numbers. So if the sequence is really random number, is really random, it will pass some tests. Actually, in the next slide, I will tell you about those tests. Let's skip to them. I will show you the tests first. These tests: frequency test, Rands test, and Moray universal statistical test. These are the tests. If the sequence passes all these tests, it will succeed to be considered a random number. Okay. Here we have to differentiate between three types of random numbers, of random sequences, creation of random sequences. The true random number generator, this uses the source of randomness, like the clock of the processor, like the animation of the motion of the mouse, maybe using any other source of electricity, and then conversion to binary, and then create a random bit tree. For example, the most common one is taking an analog electricity value and then convert it to digital, and then take this random bit tree. This is natural source of randomness. So we call it true random number generation. The second one is not natural, but it uses an algorithm, deterministic algorithm. As I told you, the deterministic means it will repeat itself after a while. It will repeat itself after a period. So we call it deterministic algorithm. It needs a value of seed value. This is a startup value, and then continue to create random numbers and until it repeats itself again. So this is pseudo random number bit stream. Okay, and we call this pseudo random number generation. And the last one is using deterministic algorithm also. Okay, but this is not using algorithm but uses function. So we call this is a pseudo random function. Pseudo random function. And the difference between the PRNG and the PRF is only that PRF is creating specific length bit stream. It creates a specific length bit stream or creates segments of bit streams. But this one created an endless sequence of bit stream. These are the main difference between the PRNG and PRF. What about the true random number generation? Takes an input source that effectively random, as I told you, from nature, and the source is referred to as entropy source. Entropy source that has entropy source means it is not constant, it is not uniform. Entropy means not uniform. Has the probability, the characteristic of randomness. I cannot take, for example, very, for example, the clock, the clock with seconds and minutes. I cannot take seconds as a random number because it is not entropy. It is uniform. It is uniform. If it is uniform, it is not random. I want random source, so we call it entropy source. And that is drawn from physical environment of the computer. Just like keystroke, timing patterns, disk electrical activity, mouse movements, and instantaneous values of the system clock. We can use these natural sources or physical sources as an input to true random number generator. The source, or you can use one source or many sources, serve as input to an algorithm that produces random binary output. That's why we use the entropy source. As I told you, this is shouldn't be uniform, shouldn't be creating sequence or predictable sequence. So the true number, the true random number generator, or TRNG, may simply involve a conversion of an analog source to binary output. Maybe it's just a simple analog to digital conversion. And you know about analog to digital and digital to analog conversion. Maybe this is the simplest way, is to take an analog signal and then convert it to digital or binary output. So also the TRNG may involve additional processing to overcome any bias in the source. This means maybe the source is biasing toward values. Biasing means that it prefers some values other than others. For example, if the coin is unbiased coin, whenever you throw it, it will create either head or tail with equal probability. So the probability of head equal the probability of tail equal 0.5. But for the biased coin, there is a probability of head greater than the probability of tail or vice versa. So the coin prefers some values. So for example, maybe the probability of head is 0.75 and the probability of tail is 0.25. So this is biased head, means that it prefers some value compared to other. So maybe we include some additional processing to overcome this bias in the source. And pseudo-random number generation. Here we talk about the true random number generator, the first one here. We talk about the first one, okay? We have it, we can check it like that. Okay, we finished this one. Now we move to the pseudo-random number generation. And this one takes an input, a fixed value. This value is called the seed, and produces a sequence of bits using the deterministic algorithm. And I told you deterministic is a problem because if it is deterministic, it can be predictable. So even sometimes the seed is generated by true random number generation. The output bit stream is determined solely by the input value or values. So an adversary who knows the algorithm and the seed can reproduce the entire bit stream. So we have two information here is very important. The seed value, this one, and the algorithm used. These two information, if known by the attacker, he will be able to recreate the entire bit stream. He will be able to create the entire bit stream or reproduce the entire bit stream. These two information. That's why it is deterministic. Other than the number of bits produced, there is no difference between PRNG and RF. As I told you, only the difference is this one creates fixed length bit stream and this create endless bit stream, very long bit stream. This one creates specific length bit stream. So the pseudo-random number generation, it is used to produce an open-ended sequence of bits. As I told you, this is endless sequence of bits. Input to a symmetric stream cipher is a common application for an open-ended sequence of bits. We can use this as a key for the stream cipher. We can use the pseudo random number generator as a key generator for the stream cipher. And for the pseudo random function, this one is used to produce a sequence of bits of some fixed length. And this is the most important characteristic compared to that one, to the PRNG. Because PRF creates a fixed length bit stream. Examples are symmetric encryption keys and nonces. This can be used in the symmetric encryption keys and nonces if you want to create a number for just one time. These are the applications of the pseudo-random function. The PRNG requirements. Now we covered the three. We return back. We covered that one, the true random number generation, and we said that it is using natural source. And here we use we explained also the pseudo random bit generation. And we said that there are two important information, the seed and the algorithm. If they are known, the attacker will be able to recreate the entire bit stream. And the last one is the pseudo-random function. And the pseudo-random function create a deterministic bit stream with a fixed length. Fixed length. And those are, we have covered them. Do you have any question? You have any question of the on about the random number generators? Any question is welcome.
Doctor, can you explain again about the BRNG, like fastly?
The PRNG, the one in the in the middle,
No, the previous, no, not the slide, the previous one.
the previous slides. This one,
Yes, this one.
which part you
The
mean?
BRF.
Yes, the PRF. Yes, the PRF is the same as PRNG exactly, but the difference is it creates a fixed length bit stream. It creates a fixed length bit stream. That's
Doctor, you are telling bit stream?
bit stream. Yes, fixed length bit stream. Okay. Yeah, you hear it different word.
Yes, that's why I was asking.
So what the other word that you hear? The bit or
Yeah, I thought like it's bid stream.
okay, okay, okay. So it's bit stream, okay. So this is the main difference between the PRNG and the PRF. And now we can move to the we can skip all of these three because we are going to use this in our algorithm. We skip this one for now. We just concentrate on the one on the middle. We're going to explain it in detail. Okay. We explain the PRNG requirements in detail. The PRNG. The basic requirement of the PRNG or PRF is used for a cryptographic application. The adversary who doesn't know the seed is unable to determine the pseudo-random string. The pseudo-random string. So this is the most basic requirement, is that nobody knows the seed, he cannot predict the algorithm, the bit stream. The requirement for secrecy of the output of the PRNG or PRF leads to specific requirements in the area of randomness, unpredictability, characteristics of the seed. This means we concentrate on the secrecy of the output. We have to make sure of randomness and the unpredictability and make sure of the characteristics of the seed. And we cover all of these in detail. The randomness. So we will cover the randomness, then unpredictability and the characteristic of the seed. One by one. The first one is randomness. Randomness means, as I told you, just remember this word. All bits have probability of 0.5. This is the most important characteristic to say if this bit stream is random or not. If all bits have probability of 0.5, this means this bit stream is random, okay? And now the generated bit stream needs to appear random even though it is deterministic. Even if it is deterministic and we know that it is going to be repeated after a period, I should have the characteristic of randomness. And there is no single test that can determine if a PRNG generates a number that have the characteristic of randomness. Actually, there is no single test for that. We cannot have single test. We have many tests. You cannot apply one test and then check the randomness. This is impossible. You have to check more than one test. That's why he said There is no single test. Actually, there are many tests. I will tell you about three of them in the upcoming slide. If the PRNG exhibits randomness on the basis of multiple tests, then it can be assumed to satisfy the randomness requirement. That's why if it passes more than one test, then this means we can consider the bit stream is random. And for the next SP special publication, this is SP special publication for the specific, for the 22 is specific for the tests that should seek to establish three characteristics. Uniformity, this means all bits have a probability of 0.5. Scalability means that any subsequence should also be random. And consistency, this means with different seed value, we get totally different bit stream. These characteristics of randomness are enforced by the tests of the special publication 822 of National Institute of Standards. These tests, and we have also 15 separate tests of the randomness. 15, they are too much, but we have included here the most basic tests that must, any sequence should be random only if it passes all these tests. The first one is a frequency test. The frequency test means the number of ones equal the number of zeros. Approximately equal, not exactly equal. For example, if I have a bit stream of 1000, I have about 500 of zeros and 500 of ones. Not exactly 500, but any value near this value is okay. This is a frequency test. And the runs test, this is the first one, frequency test. The second one is runs test. So the focus of this test is the total number of runs in the sequence. This runs means after a while, the algorithm will repeat itself. This is one run. So the run means the purpose is to determine whether the number of runs of ones and zeros of various length is as expected for a random sequence. Means that if you know that it is going to repeat itself for each run, we have the probability of a frequency test. We have a probability of having zeros and one for each run, I mean, you know that it is deterministic. You know that the random numbers or the pseudo random number generators are deterministic. Means they are going to repeat themselves after a while. For each repeat, we have to make sure of the frequency test. We have to make sure that the number of ones, number of zeros, they are equal, approximately equal. And the last one is Moret test. Moret test is if we can compress the binary stream, if we can compress the binary streams, this means it is not random. If we can compress the binary stream, this means it is not random. For example, do you know how to compress binary stream? Anybody know any idea about compressing bit stream? Any of you knows about this, the compression? Any simple idea, no problem. Tell me a simple idea about the compression of the bit stream. Anybody knows? Anybody, you can write on the chat, no problem. Anybody knows about the any idea of compression? Any idea of compression? Nobody knows anything? How to compress a bit stream? Do you know any? Do you know any idea?
دكتور والله ودنا نفتح المايك لكن في الدوام مداومين.
طيب ماشي. عبد الله احمد ولا مين؟
لا سيف السويدي انا.
سيف. طيب يا سيف. طيب اوكي. You can write on the chat, no problem, if you have any idea. Anybody knows any way of compressing? How to compress? Nobody knows? Okay, let me tell you. For example, if I have a sequence of bits like this, that one, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. Okay? This is a bit stream. I can compress this bit stream like this. I can say 1, 0, 0, and 3, 4. And 1, 1, 1 is repeated 2. And 1, 1 is repeated 1. Okay? Let's try to understand how this compression is done. Here we have a sequence with repeated pattern. We have 1 0 0, we have 1 0 0, we have 1 0 0, 1 0 0. Okay, this is repeated pattern. I can take one of them and then say they have been repeated 4 times. And if we stick to the length of 3, so we have to stick on the entire bit stream, so we can take 3 by 3 bits. Then we have 1 1 1 and then 1 1 1. They have been repeated 2 times. And last 2, they have been repeated 1 time.
دكتور ليش خذينا 3 عقب 2؟ ليش مو ب4 4؟
Because they have been repeated 2 times. 1 1 1 and 1 1 1 is repeated 2 times. So 1 1 1 is repeated 2 times.
زين دكتور 4 إذا خذينا 4 2 times repeated يعني 1 1 1 1 1 1.
But we have to make a fixed length. We have to fix the length. The length is 3 bits. So I have to select 3 bits each time. Okay, so
Okay, دكتور.
we have selected 3 bits here, 3 bits here, and the last 2 bits. Because we don't have a third one, so we take only 2 bits. Okay. As you see, if we can compress the binary stream, this means it is not random. As you see, this is not random because it repeats itself. So if it can be compressed like this, it is not considered to be random. So the first one is frequency test, means the number of ones and number of zeros. Run test, any subsequence should be having the frequency test, means that the number of ones and numbers of zeros are approximately equal. Any subsequence or any run of the algorithm, subsequence or run entire sequence of the output of the random algorithm should be having the frequency test, means having zeros and one are approximately equal. And the last one is a Murray statistical test, means if the algorithm cannot be compressed, this means it is random sequence. Okay? Any question about those?
So doctor, run test and frequency test, both of them are approximately equal in zeros and ones?
Yeah, but this is for the frequency test of the entire bit stream. This for the entire bit stream. This for subsequence. For example, I can have the entire bit stream with ones and zeros approximately equal, but for some specific parts of the substream or some specific part of this stream, the number of ones and zeros are not equal. This is not good. You understand? So I can count the total number of ones and the total number of zeros, they are approximately equal. But if I take a small segment of the bit stream and test it, I will find the number of ones, for example, more than zeros. This is not good. It should be the same, either on local substream or the entire bit stream. Okay?
Okay, doctor. So the run test, it's the subsequence should be having zeros and ones, right?
Yeah, equal number of zeros and ones. Okay?
Okay, doctor. Thank you.
Okay, so here, unpredictability also, I told you about. If we return back to the slide, here, yes, uniformity, scalability, and consistency. This scalability, yes, this one. Randomness, unpredictability. I told you, randomness and unpredictability, both of them should be existing in any random algorithm. Not only one of them, because maybe the sequence or the random stream is the stream is random, but it is not unpredictable. It is predictable. If it is predictable, this is not good algorithm. So here, unpredictability, the stream of pseudo-random number should exhibit two forms of unpredictability, the forward and the backward. The forward means if I have the seed and the next output bit in the sequence should be unpredictable in spite of the knowledge of previous bits in the sequence. If I know some bits, I cannot predict the forward bits, the next bits. I cannot predict them. And the opposite way around, the backward unpredictability, if I have the seed, I have the current bit stream, I cannot predict the previous values of the bit stream. We can say, in other words, we can have no correlation between a seed and any value generated from that seed should be evident. No correlation. And the last important characteristic is each element of the sequence should appear to be the outcome of an independent random event whose probability is 0.5 or half. 0.5 means half. Okay. So this means we have to get no relationship between the current sequence and next sequences, no relationship between the current sequence and the previous sequences. This is unpredictability. Because if we have this relationship, the attacker can create or can guess the next substream, or using the current stream, he can guess the previous bit stream. And also the unpredictability, we can use the same tests for randomness and they also provide a test for unpredictability. Actually, if we have truly random truly random bit stream, we can have these tests. If they pass all these tests, we can conclude that it is unpredictable. So there is no correlation, as I told you, there is no correlation between the value, any value on the bit stream and the seed. So for example, we have a seed, we have a correlation between the created bit stream and the seed. For example, if the seed is 10, we create different value and compared to 9 or compared to 8. No. At each time we create the same random, not the same exactly in random. I mean, we create different, but with the same properties, which is the number of ones and zeros should be equal. The probability of each bit is 0.5. This characteristic should be the same for all bit streams. Okay, so the seed itself, this is maybe you will say the seed is not clear for now. I cannot say why we need a seed. It is the initial value of the stream cipher of the for the random number generator. This is the initial value. If you know about the recursive formulas, this means the initial value of recursive formula. Okay, recursive means that we have to make an initial value and then make a loop after that. That's exactly what's happening in the PRNG. We have initial value, which is the seed, and then we start to make a loop, and then create in each loop, we create one bit. And also the seed itself must be a random, pseudo-random number. We have to make sure that nobody can guess the value of the seed. Nobody can guess it. And typically the seed is generated by true random number generator, which depend on the natural phenomenon or physical phenomenon. So we have the entropy source. This is how PRNG is created, or the generation of the seed, like that. Entropy source. Then the true random number generator creates a seed, and then pseudo random number generator, then a pseudo random bit stream. Okay, I think we have we can stop here at this slide, but I just wanted to tell you about the packages that you should be familiar with. I want to tell you about the packages. Before leaving, we can talk about the packages that you should be familiar with. We have, you know about Python? Anybody knows about Python?
دكتور هو شرات الكودينج؟
Yes, doctor, law programming language.
Yes. It's used in coding, the programming language, but the most important characteristic of Python, it is used by hackers. You are specialized in the cybersecurity track, so you don't know about scripting language. It is difficult to know that. For example, if somebody want to hire you as a cybersecurity specialist, they will make sure that you can write scripts. You can write in any script language, for example, MATLAB or Python. But now the most important is Python, because this is really what hackers use to make an attack. If they want to program something, they use scripting language like Python. I don't know if I can introduce some the next slides or the next lectures if you want me to teach you Python or not. Are you agree with me about that? I can teach you some of the basic programming of Python.
دكتور إذا علمتنا بتدخله في الامتحان؟
Oh my God. This is very hard question really. Because
دكتور علمنا بدون ما تدخل.
if you want to learn anything, you have to practice it. If you don't practice it, you will never gain an experience.
أوكي نحن will practice لكن بدون exam عادي.
Okay, what about the others? Okay, Frial, I understand you want not to take more load because you have already some other subjects you study too hard. So what about the others?
والله دكتور ما عندي أي مشكلة، أنا ناخذ البايثون يعني.
اوكي طيب حد يعرف اي حاجة عن البايثون؟ Anybody knows any background about Python?